I want to welcome you all to our webinar. This morning, we're going to be talking about wireless monitoring and when Wi-Fi is the right monitoring solution for your application. Today, we are joined by Michael Hadt, who is our Account Manager Midwest at RLE. He graduated from Indiana University in the Kelley School of Business. He has more than 12 years of industry experience connecting technology to solve problems in mission-critical environments, and Mike's expertise lies in his extensive knowledge of building controls, product applications, and how to connect data to analytics. He is such a great presenter for this topic this morning because Mike is so passionate about our wireless products and BMS integration. He's a great fit for this presentation. Joining him is Brian Jones. He's a firmware engineer at RLE. He has field installation experience with our products and their applications. He fields a lot of our technical support calls. His expertise in Q&A and internal test, and also in the firmware and hardware design of our Wing and Wi-Fi products makes him a great fit for answering any of your questions today. He is the Wi-Fi guru at RLE, and we are very grateful to have him here with us this morning. So this morning, we're going to be talking about the advantages of wireless monitoring, and then we'll look a little deeper into when you use Wi-Fi versus Wing and the available monitoring options that we have for both lines of products. Mike's going to talk about the 6 concerns of wireless and security that he frequently hears when he's talking with customers and facility managers. Then he's going to walk us through how you set up a Wi-Fi-TH transmitter with RLE's products. He'll look at standalone monitoring versus integrated and our protocol solutions that are available there. And then we will look at how our technology is actually being integrated into data centers and other buildings right now to solve problems. So at that, I'm going to turn it over to Mike.
Thanks,
oh,
Jenny.
Sorry, one more.
Yeah.
Sorry, Mike, I forgot one thing. So we will definitely have time for Q&A at the end of our webinar this morning, and Mike and Brian are available to answer any of your questions. So as we go, we just have you all on mute out of respect for Mike and Brian and for everybody's time this morning. You can throw your questions into the chat and I'll moderate them at the end. If you don't want to ask your question in the general chat to everyone, you can use the drop down and send your question directly to RLE, and I'll make sure it gets asked at the end. And with that, I'm sure I'm done now. So off you go, Mike.
Great. Thank you, Jenny. Thank you, everybody, for attending as well. This is an exciting topic. I do love talking about wireless technology, especially RLEs, mainly for the biggest reason: it works. You know, really, I'm asked a lot about the advantages of using wireless, and obviously there's obstacles with any project, typically cost, timeline to deliver, the manpower to actually deliver that. Sometimes it's even IT. Ultimately, I think the biggest advantages of wireless is streamlining the efficiency for immediate deployment. And with our wireless technology, we're able to bypass all obstacles that typically prevent progress from ever getting started. I know there's a variety of different folks on this call, and I think you're probably all shaking your head a little bit, thinking about what's typically prevented progress from ever getting started with a lot of jobs. And, you know, wireless technology is one way to really kind of do that. You know, so what data do you need? Where does it exist? You know, the future will continue to demand connectivity where it's needed most, at the edge. Speed of processing, AI, IoT, analytics are all driving innovation to connectivity. Energy demands will continue to grow, and the balance of renewable energy will continue to get better as new data centers are spun up and existing buildings require you know, more advanced demand ventilation strategies. So with that, you know, the sensor connectivity market is going to continue to multiply year over year, especially in this unfortunate scenario that we're all in globally here. So, you know, RLE's Wing and Wi-Fi wireless is enabling visibility, alarms, and advanced control strategies across enterprise networks around the globe, really helping to protect the different data centers and all the other assets under any critical environment. So what works best for you kind of depends on your needs and, you know, what kind of environment do you have? What are you trying to get out of that environment and why? So when to use Wi-Fi versus Wing, we're kind of looking at this from maybe an individual building perspective versus a campus or an enterprise perspective. Wi-Fi is great because it can provide coverage across large areas through a pre-existing Wi-Fi network. All right. Now, on the other side, Wing are radio transmitters, and we'll get into some of the pros and cons on the next couple slides. But every building I've ever walked into with our Wing product, I've been able to make work with reasonable expectations, and in many cases, far surpassing expectations with the range that our radios are able to communicate. And I think that's really probably one of the scariest things of anything wireless, typically is battery life, the cost of deployment, the data that's actually being produced, the age of that data, and a variety of other factors that typically make wireless a little bit scary. And we'll also touch on some of the security aspects, which really I think should solve all questions and concerns about RLE's wireless capabilities, and really help to drive different opportunities throughout the different buildings that are there, right? So, really the one of the pros of, what we're trying to accomplish is network access and leveraging existing infrastructure, but sometimes that doesn't exist. So, with our 900 megahertz and 868 megahertz radios for international, we're able to immediately deploy technology, especially with the Wing radios, and immediately start gathering data to help, ultimately solve different problems that exist. So that's why I get excited about the wireless, because of its scalability and ultimate, capabilities of connecting different data to solve different problems.
Hey everyone, this is Brian. I just want to take a moment to go over some of the pros and cons to both our Wi-Fi and our Wing solutions. So our Wi-Fi, it really thrives in a situation where there's a distributed environment, like a university campus or a workplace campus, where you have a lot of different buildings you want to monitor, and you have a network to all of them in place. We have support, IPv4 support for our existing Wi-Fi-TH sensor. We're adding IPv6 static support for all our sensors. Our data, or your data, is secured through the network encryption. So you can see we provide standard encryption types there. Our battery life, we're very proud of, 5 years or more for our Wi-Fi sensors at the default transmission intervals. Then you can easily integrate it into an existing building management system. You can use BACnet, Modbus, SNMP. We allow monitoring of temperature, humidity, Wing Manager's dew point calculation, and leak detection. We see a lot of future growth opportunities to build now off this proven Wi-Fi-TH architecture that's been in the field. So we just feel good with this going forward. And also our Wing Manager, which is, in the past always been used for our Wing sensors, also has support for our Wi-Fi sensors. So the sensors can send packets to the Wing Manager, and that can process all the data for you. It supports up to 400 sensors, can be either type. And then in our Wing V2, we also added an integrated map, so just a really good way to visualize your data. One of the cons is you are reliant on your Wi-Fi network. So if your network is notoriously unreliable, that's definitely something to consider before you deploy a whole bunch of Wi-Fi sensors. Also, there's a little more expertise needed in configuring each of the devices. You need to set up each device as being on the network, so you might need IT to get involved. Then also the transmission frequency is lower for the Wi-Fi sensors because communicating with a wireless access point does consume more power than the radio sensors. And then also currently just our selection of sensors is more limited, but going forward, we definitely see that we'll be expanding this product line. So now onto our wing sensors, our 900 megahertz for the States and then 868 internationally. Big advantage is it doesn't rely on any network. It's actually really easy to set up. You just pull the battery tab and it's communicating. It really is that simple. And although it couldn't communicate, say, across like an entire university campus, they do still have significant range. We have seen up to 600 feet line of sight. And then if you add one of our range extenders into the mix, you can also get an additional 1,000 feet. So this portfolio of wing sensors is also a little more complete at the current time. So something just to keep in mind that there's a few more, I don't know, different things that you can monitor right now currently. And then our battery life can be really good. Our most popular sensor, our WIFI-TH, can be up to 12 years of battery life. And that's transmitting every 10 to 20 seconds. And that's all our wing sensors are transmitting every 10 to 20 seconds. The communications are secure. They're one way to the manager. It's proprietary packet structure. And then also you get the same benefits of using a wing manager. You're alarming and trending. If you're using a wing manager v2, it supports TLS, so you can have secure email and HTTPS connections to secure your web page. And then again, the integrated map. I would say probably the biggest con to wing is just the deployment expectations. The sensors, they have great range, but they are still limited. So it's really ideal for contained solutions like, say, a data center where you have a single room with a lot of sensors, although it doesn't only fit that expectation. You can also add a range extender, but just be aware it's another piece of hardware in the mix.
Great, thanks, Brian. And I would actually add to that in stating that we've a contained area like a data center is obviously a great example of leveraging our wireless wing technology. But I've worked with a couple different schools and universities as well as commercial buildings and have successfully been able to transmit data hundreds of feet across this building reliably, simply using the wing manager and the range extender. So certainly don't be afraid of giving it a shot, because more often than not, it is going to work. So as Brian had mentioned, the Wing Manager V2 does have some standard features like the TLS and HTTPS integrated map.
Hi, hold on.
We've added the temperature, humidity offset, some additional advanced logging functionality, direct alarm notification. I think Brian mentioned that you can actually use both the Wi-Fi and the 900 megahertz sensors together. Good use case. I'm doing that today actually at a school location. The scale of all this is, again, up to 400 sensors. And we're mentioning a lot of this because it fits the standalone model, but it also provides that integrated migration path as well, should you not have that infrastructure in place today. But it's something that you need to help get to that next point. Certainly is, some very valid tool to actually get you from point A to point B. Then the other big thing comparative to a lot of the other technology out there is that there are no reoccurring costs or licensing fees, maintenance or things like that. So certainly, a proven device already. And again, the integration methods are extremely solid as well. So when I look at wireless technology and kind of what am I doing, what are you doing, right? Ultimately, you're enabling connectivity. So I like this little diagram because it fits almost any building architecture infrastructure that exists. So in the top left corner here, you'll see our Wi-Fi sensors, which is the temp humidity. We're launching the Wi-Fi leak detection here, as well as the Wi-Fi one wire. So few applications for that is obviously temp humidity in any kind of a room, or the one wire, maybe a refrigerator, freezer, or a duct, or even taping it up to a pipe for like a boiler or something. But imagine now how easy it is to deploy wireless technology Wi-Fi across a larger building infrastructure that does have all of the access points and everything, and really getting your leak detection. I mean, that's one of the things that's unfortunately overlooked in a lot of these buildings, but I think everybody on this call probably knows somebody or has experienced some kind of a pipe bursting this winter. I mean, it has just been brutal. So, I know I've had a lot of calls here recently in helping to kind of promote risk avoidance, right? So if we're able to trip a leak early, we can create an alarm or even another condition where maybe a water valve would close, but ultimately it's early detection and protection. If you look down just underneath those blue and red lines there, that the blue lines are supposed to be like an IP network, BACnet, Modbus, or SNMP, and then the red lines intended to be an MSTP BACnet or RTU Modbus network. So again, how do you want the data? How are you trying to connect it into the environment? What problems are you really trying to solve? On the left-hand side with the little tubes wrapped around it, that's our differential air pressure sensor. So we've been able to deploy that in a variety of different data center spaces, as well as different classrooms and rooms to give you pressure where you need it, specifically where you need it. The air velocity we've also used to validate air lost through all the different pipes and cables and cords and all the debris underneath the raised floors. So that's actually helped us solve some of those problems, married with that differential air pressure. You notice I do have the little gas sensor down there. That's hydrogen. So we install these a lot in some of the battery charging areas. And I kind of strategically have this wing manager there on the left-hand side, or the range extender, because that's what has the ability to extend range to the wing manager. Okay. If you look just slightly over past the camera and the alarm signal there, you'll see the little temp humidity transmitters as well as the temp. These guys are slick. They fit almost any environment, and they have little magnets on the back. So again, inside of your data cages and things like that, they're very simple to deploy and move around. Our wireless leak detection, again, this is the 900 megahertz version. Another neat application that I've worked with a lot of folks on is actually getting boiler temperatures alarms. So if the pipe was to drop below, let's say 110 degrees or something, you'd be able to get that alarm. Or in some cases, water temps might be at 180 degrees or 160 degrees, way too hot. So you'd be able to create some efficiency and cost savings by understanding that data value. And then our power fail monitor is connected to a digital input, basically tripping on a power loss. So the guy that I missed in the middle there is the BMS wing. That's kind of our zone wireless detection system, and it's very easy to deploy. And if you notice, it's only connected to the red link. So BACnet or Modbus RTU, BACnet MSTP are the only ways that you're going to be able to get that to communicate. A lot of IT folks prefer this model just because it does not have any way to touch an IP network. But if you look at the wing manager again on the left there, you'd also be able to see that, with all the web user interface, and we'll go through some of that here shortly, all of the setup just becomes streamlined and easy with all the other bells and whistles. And if you did not want it to sit on the network, you can use that IP port on the manager to set everything up and then just connect it to the MSTP network, let's just say, and have all that data transmit over that communication link. And again, I'm showing all of this communicating up to the enterprise, which could be our FMS solution. It could be another DSIM system. It could be a BMS or even some other analytic or dashboard trying to provide data and some different alarming as well. So if it was standalone, you see that we do have the 2 relay outputs and would easily be able to trip a siren or a strobe light or something like that. But I like showing this camera option because there's a lot of environments, especially now, that are remote, and you have cameras there, but you don't want to run them 24/7. You want them to trip on a condition. So if you have a leak or you have a smoke detector that trips one of the wing DIs, or some other failure that would cause a condition to tell that camera relay output to start recording. So the integration of all the different technology and solving the different problems that exist is really what I get excited about, because I just think it's cool to be able to do it. You know, and it's open in the sense that I don't care whose technology is on the head end of it, as long as it has a way to communicate BACnet, Modbus, or SNMP, we can enable that connectivity to solve those problems.
Yeah, so this is our Wi-Fi-TH sensor. It's been on the market for a little while now, I'd say maybe a year. Connects to 2.4 gigahertz wireless network. You can see the standard types of encryption that it supports. Supports the Wi-Fi, IPv4, static, or DHCP, and then we're adding IPv6 support for all our sensors, including this sensor. We're really proud of our battery life, 7 years at 5-minute transmission intervals, but that transmission interval is also modifiable, 1 to 30 minutes, kind of whatever your needs are. And then there's some benefits, again, to integrating with Wing Manager. You can use a BMS or packet dissector to handle all the data processing yourself. Our packet information is available, but you can also use the Wing Manager to integrate with BACnet, Modbus, SNMP over an IP network. There's also RS-45 for BACnet and Modbus, and then our BACnet IP. Also, you can use a custom UDP configuration, so that might be useful in some situations. And then you have our new sensors that are just about to be launched, the Wi-Fi LD and the one wire. Both sensors up to 5 minutes on the default transmission intervals. The Wi-Fi leak, I just want to point out, it does wake up regularly every minute to check if there's a leak on the cable and it sends a packet right away if there is. We just didn't want customers to feel anxious that if there's a leak, they wouldn't get an alarm for 5 minutes. You get it within 1 minute.
Well, it'll wake up on that alarm condition as well.
Yes, yeah, it's checking continually. And then our one wire, I think, would work well in an application for places where you can't place the sensor itself, like a freezer or refrigerator or an oven. That might be okay for kind of mild temperatures, but if you get more extreme, you want your sensor probe on the outside, or your sensor on the outside and the probe to go inside. And then again, you can integrate it in the same ways with a BMS, packet dissector, or with a Wing Manager.
Great, thanks, Brian. So I mentioned this product earlier, and I just wanted to spend just a moment on it because this is such a great way to add wireless to any environment that can connect BACnet, MSTP, or Modbus RTU. We've seen intelligence added to different environments where generators or other mechanical equipment has relay outputs that trip. We've taken our analog transmitter and connected 0 to 5, 0 to 10, 4 to 20 milliamp outputs of literally any sensor on the market. As long as it produces that output, we can take that data point and pass that through and integrate it so that your optimization goals are achieved. The greatest story is my colleague Jen had sold some of these BMS wings to a high-rise here recently, and they deployed the wireless leak detection and spot detection. They got a leak at like 4 in the morning and were able to actually, the integrator was smart enough, since it was in the penthouse of the high-rise, was actually smart enough to integrate a water valve to shut off. So when they got the alarm, they didn't have 9 floors of damage to remedy. So, again, thinking about the existing infrastructure that's there, how many sensors got missed? I know there's some guys on the call here that really produce and make sensors that are the 10K2 or even the RTD sensors, 1000 ohm platinum sensors. Again, giving you that flexibility to create deployment strategies that probably didn't get covered in the initial bid, or due to space allocation or the way that the building needs have changed over time. again, it's a simple way to connect up to 50 sensors on this guy. And keep in mind, since it's not IP connected, there are no Wi-Fi sensors that will communicate with this either. So with that, I've come across regularly, as you all probably do, some objections that typically come up. And one of the biggest things that RLE is trying to help provide is education around the security of our technology so that you can overcome those objections and provide the IT environment a reliable, secure product that they don't have to worry about. So, the one objection I typically help to overcome is my IT department won't allow Wi-Fi devices on our network. So our wing sensors will only talk directly to the wing manager over special frequencies allocated for the industrial equipment. The wing manager itself is where all the data is collected and analyzed before being pushed over a standard comm trunk network, right? And then also, the security aspect of our Wi-Fi sensors are the encryption, standard encryptions required in the market. Someone will use, this is a big one here, someone's going to use our wireless signals to hack into my network, disable all the alarms, manipulate the firmware in the manager, download different data. So, this is a big one. Communications from the wing sensors to the wing manager or the range extender are one-way communications again, right? One way. We're not passing data back to the sensor for any kind of, logic if-then occurrence. That's why we're enabling connectivity to all those existing controllers that are out there, because you already have the controllers out there. You're missing some data points to add intelligence, right? And the other big thing is, the firmware, all the alarm settings, configuration, those are all stored on board the wing manager, and none of that is ever transmitted wirelessly and cannot be changed via the wireless interface. Also, the security function of the TLS 1.2 allows you to put your own certificates and private keys for securing that web manager or wing manager device. And then also, as I think I mentioned earlier, after setup, you can fully disconnect this wing manager from the network or the BMS wing, never having been on the network. But you can set it all up with the wing manager and then fully disconnect it so that literally all you have is that secured BACnet MSTP communication signal going to the head-end controller. Could be an FMS, could be, like I said, a building automation system, legacy system. So the other thing that often comes up is that wireless sensors seem to be unreliable in the data that they provide. Every wireless packet contains a cyclic redundancy check to ensure that the data has not been corrupted during transmission. And if it was, by any random stretch, that data point will be ignored automatically. By configuring the wing manager to listen only for the sensors that you're setting up and the serial numbers dedicated to it, you're really only seeing the data that's meaningful to your environment. Wing Manager also manages signal strength per device in real time. Again, that's one of the biggest challenges with wireless is how good is my signal? The other big one is battery and alarms of that battery, covered, check. Offline alarms or even alarm delays, all configurable in the Wing Manager as well. And then here's a big one that I learned with one of my other guys I was integrating with is, he was sharing with me some of the other technologies that exist. When it falls offline, it's got a stale value. So now think about that. You're controlling off of a stale value that you don't know is stale. So we provide the age of the data, again, which is communicating every 10 to 20 seconds with our radio transmissions. And then on a Wi-Fi side, it is an interval. So 300 seconds for a 5-minute interval. And again, if I generally like to put on a Wi-Fi maybe a 16-minute offline alarm. So let's try to send 3 packets before we trip an alarm, because again, we want to minimize those. But this is a good way, another tool actually to understand how good is your Wi-Fi network. You may need more access points. Let's make sure we state that. Just because you got Wi-Fi doesn't mean it's good Wi-Fi. And then, wireless could introduce another point of failure. Well, I would argue that UPS system failures, water leaks, crack units failures, as well as generator issues are the biggest problems inside of data centers, not the wireless sensor. We're actually helping you identify those before anything else occurs that could be mission critical or detrimental to that space. And then other building problems that exist are boilers that fail. Again, water leaks, maybe pipes and ceilings or external walls. Not good. Also using these for fresh air requirements and building pressure, compliance. And here's one I just had a conversation about the other day. I threw this in is there's a lot of sensors that exist that have not been commissioned or checked in a long time. So once again, now you're actually controlling based off bad data. Not good, in my opinion. So, we're using wireless sensor network to identify problems, allow you to address infrastructure and comfort issues before they become critical or even create downtime. So here's the next one. Inevitably, wireless is more expensive due to all the costs and the fees. Once again, Wing platform and sensors have $0 reoccurring costs or fees. All of your data, again, is stored locally in the Wing Manager 30 days at a time, downloadable, exportable as well. And you own it. That's another big thing. We don't own the data. You own the device. You own the data. Again, more expensive because of battery replacements, the time to go send a facility engineer to go check all of that. With a 12-year battery life, you're not doing that very often. So, and then the other nice thing is the flexibility to add or relocate sensors in your space as requirements change. I know space allocations are certainly changing, and demand ventilation strategies are causing that to some degree as well. So, being able to scale this system as well is another great way to lower your initial ROI, but then also take advantage of an infrastructure that already exists that's easily added to. So here's the other one that comes up, not too often, but every so often. No respectable industry leader would consider trusting a wireless platform. Well, the annual listing of 10 companies that are at the forefront of providing facility management solutions and transforming businesses is RLE. We've recognized here by CIO review, and we work with a lot of industry leaders, and they've tested this technology, they've put it through the paces, they've approved it, and they love it. The ease of use, the cost point, the reliability have all far surpassed industry expectations and reviews. So we're going to touch on a quick demo here, but I wanted to add this screen mainly because this is the hardest part of getting connected to any Wing Manager. Changing your IP address on your laptop to be able to connect to the default IP address on the Wing Manager. So I wanted to include this slide just because there's a lot of people that are afraid of technology. Don't be. Don and the engineers and Brian and Ryan and the rest of the guys really put a lot of effort into building this in a way that streamlined some of the complications that other systems may involve. So with that, Brian, did you want to touch on what we would need?
Yeah, definitely. So obviously you need one of our Wi-Fi sensors. So right now that's our TH-LV or one wire. And then you need a standard micro USB cable. It does need to have the data line, so just be aware some non-standardized cables might not have that. And then you should download a terminal emulator or serial console like PuTTY or TerraTerm to connect to the device. You'll need a wireless network, laptop or PC, and then especially if you're setting up a static network, a list of available IP addresses from the IT department. And then just follow our quick start guide online. There really aren't too many steps. And actually, Mike has a really nice video on the next slide that kind of shows how simple it is.
Great. And I will add to that. Twice I've been called to provide some basic technical support because they couldn't get connected to the Wi-Fi sensor. And the reason for that was ultimately they were using a phone charger and not the micro B cable with the data port on it. So be mindful, not all phone chargers have that data point. So here's a quick little video that basically walks through what we just discussed right here from, what you'll need to get started. It's about 2 minutes. We'll walk through this basically from cradle to grave. Once you receive your Wi-Fi-TH sensor or Wi-Fi LB or even the one wire, initially this is the TH and this is how you would ultimately set it up. So just follow the screen clicks here. Here should be a little video. So I'm going to go download the quick start guide. So I'm kind of just touching base on where it exists in the resources. Here's the guide. In the middle here is really the core 6 steps needed to really set this up. And you'll see here shortly how easy it really is. There's also some other commands and advanced commands that help to fine tune some of these sensors should they fall offline. So what I'm doing here is pulling up Device Manager, going to what port is this Wi-Fi sensor on in my computer, port 5, COM port 5. So now I'm pulling up PuTTY, making sure that all of these points are typed in, 115200 serial. Here, I just for fun thought I'd create a shortcut. Do make sure every time that you are checking your COM ports on these. Sometimes different computers may change. So once you get this logged in, this is basically what you're going to see. So you're just going to follow this and configure a wireless network, find it, set up your password authentication, your sensor IP, your net mask, your gateway, all the way down. It's really not as challenging as most would think. That last screen was some advanced commands. Once you get it all set up, you're going to go into your Wing Manager here, look at some of the different wireless network metrics. Here's our integrated map. I like showing the wireless network metrics again, because that's one of the biggest concerns really with anything wireless is it good? Do I have a good signal? Is it a good range? So here I'm going to go into the search, type in a little Wi-Fi. Here's one that was just configured and put into the classroom. Notice my alarm notification settings. If you need to make changes or customize that in any way, obviously hit save after all those. And then all you integrators, this is the data you need on every sensor is available online. And then this wireless network metric is actually how strong the access point is. And then once everything starts communicating, here you'll see we're able to trend this data. You can download or archive log some of this data as well. So I would like to think that I made it look pretty easy. There really is no other smoke and mirrors around it. If you need help on your first one, I'll obviously let us know. We're there. But once you get going, I haven't seen anybody slow down with those. In fact, it's growing in more popularity than anything. So, after we set up all this technology, Wing Wireless, right? Why are we doing that? To solve different problems that exist in the different environments that we're at. So I thought I would sit down the other day, and just in the last 3 months, conversations I've had with partners and users, customers alike, figure out what problems have we helped them solve. So I thought I'd kind of just put a little list out here of different things that we truly did. Again, being in mission critical spaces and the growth of data centers and the impact they have on all of us being able to even be on this call today. One of the biggest things that we see all the time with our Wing THs inside of these different data cabinets is being able to identify hotspots. So then we're able to solve some of those problems with our triad raised floor panels, performance air panels, allowing air to actually get at that data cage from 3 to 7 feet better than other standard panels that are out there. Another thing I just came across the other day, a partner of mine had actually, the DAP sensor identified a condenser failure because the pressure in the room dropped, and it allowed the owner of the building to actually take steps before the automation team even knew there was a problem. So again, I think, again, being proactive and being able to create these alarms is really what we're trying to accomplish. In the school that I was just at as well, we used the DAP sensor for one of the classrooms to understand room pressure for some of their IAQ requirements and dashboarding that they're doing to make more visible how safe the building really is, right? We had another guy that I was talking to a couple of weeks ago who caught a water pipe leak in a mechanical closet that was next to an IDF room. Again, I mean, these leaks happen, and I think I mentioned this one earlier. The air velocity sensor was able to identify restricting airflow due to all the cables and pipes and everything that was under the floor. So, again, that's a way to create efficiency and ultimately generate more system optimization across all of these data points are ultimately more often than not being pulled into an automation system or at least being monitored to be able to create some analytics or diagnosis around what's going on. Had a property manager identify that their boiler busted, went down, right? The pipe strap sensor that was on there caught a low hot water temperature, which alarmed everybody from a maintenance person, a maintenance perspective, ultimately to fix that issue before they had residents and other people in that space throwing bricks at them. And then, we actually had talking with another one of my partners here, they had gas in the battery charging room in increased levels. So we integrated our analog transmitter and used the 4 to 20 milliamp output on that hydrogen gas sensor to create that alarming strategy there. The UPS, we were able to connect with our Wing DI, basically monitoring failover for backup power and generators. You can also use it for other devices that would have any normally open or normally closed switch relay. And then this is my favorite one. I've mentioned the integration of our Wi-Fi-TH on a variety of other presentations here. And this school has deployed on a large scale our Wi-Fi-TH sensors in every classroom, and basically are taking those values integrated wirelessly to their enterprise system. And then those values are then being communicated down the MSTP trunk for integrated control of each fan coil in each classroom. So what does that ultimately mean? I mean, again, anybody that knows me will know I'm a total dork about our wireless technology, mainly because it creates immediate visibility and notification to create data to solve problems. So let's say you have a problem. How do you alarm on it? What are you alarming? What's your process? I think these are all questions that we really want to address and help you to address, because what we often find is somebody thinks that just an email alarm for a water leak is okay. Certainly agree with that is one way to accomplish that. But as we found in the other environment where the 10th floor penthouse was leaking, a little bit of thought and control logic was able to close a water valve and expedite that massive problem for every floor below it. So I guess that this is more of a question. I obviously don't expect everybody to answer this, but how are you alarming? And what is your process when you do get an alarm? Are you dispatching a service personnel? Are you maybe another facility engineer? Are you calling a BAS group service team to come out? I mean, what are you trying to accomplish? And then again, I always like to make sure to note that, again, it could be an integrated platform, but it could be the Wing Manager could be built in for redundancy as well. So though you have an integrated platform into your enterprise control system, let's just say, or your DSIM system that's going to create an alarm, you can still create an alarm local with the Wing Manager and have the siren or the audible or the even a camera, take that alarm condition and do something with it. What's the impact of doing nothing is always the scariest thing to think about. So, being able to take data, create information, and then use that information for a larger cause, I think is ultimately what we're after. So in conclusion, what we effectively talked about today were some of the advantages of our wireless monitoring, when to use Wi-Fi versus Wing, some of the different options that are out there, the concerns of wireless. We also touched on that little video of setup. And then again, Is it standalone or integrated? And then how are you alarming into these things? And here's some of the problems that we've been able to solve. So don't want to chat too much longer here, but I do want to leave some time for questions and answers. So thank you all initially for attending and participating. Should you have any questions that do not get answered today, email me, email Brian, email support, email sales. Let us know. We're all here to help you, and look forward to talking to you soon.
Thank you so much, Mike. I do have questions out of the chat, so I'm going to start running through those. If you and Brian could address them, that'd be fantastic. Here we go. Question number one, only the Wing Manager V2 supports Wi-Fi sensors, right? Is there an upgrade path from the Wing Manager V1 to the Wing Manager V2?
Brian, you want to grab that one?
Sure. No, both managers support all of the current Wi-Fi sensors, so it's not necessary at this point to do an upgrade. Just you will have to upgrade your firmware to get the latest versions, and I think we have a document on that, so you can check our website, but if you email me, I can send it out to you.
And the two-parter on that one, Brian, is there an upgrade path from the Wing Manager V1 to the Wing Manager V2?
It is a hardware change, so no, to gain the new functionality, so like, for example, the encryption requires newer hardware for the hardware acceleration to do the encryption, so it does need to be the new firmware, so that's not available. You would need to purchase a new V2 if you want the mapping and TOS.
Thanks, Brian. Our second question is, what about redundancy? Can these units be wired for use if Wi-Fi goes out?
Yeah, that's a great question. I saw that there's a question about, it mentioned wired outputs. The Wi-Fi sensors currently don't have wired outputs. If the Wi-Fi network goes down intermittently, the sensor will reconnect and send a packet when it reconnects. Our design strategy was to optimize the battery life. So if you have a sensor that the battery doesn't last a long time, it would go offline. So you're in the same situation. Now you have sensors that are offline, just as if your Wi-Fi network was offline. But definitely a situation with a stable network, that's known is definitely a best use, but there's always our Wing platform. If there's any concern about that or some kind of mix, the trade-off, of course, is the range, and you might need an extra range extender to handle those Wing sensors.
Yeah, and I think that's a pro and con too from the Wi-Fi perspective. If you don't have Wi-Fi, we can't communicate on that network. So, and if you're building in redundancy, I'd say throw the Wi-Fi in there and the Wing sensors, and then you're solid, right? We can make it work.
Thanks, guys. Our next question, does the Wing Manager support BACnet MSTP over RS-485?
Yes.
Yeah, it does. We have like a web demo online too. So if there's any specific functionality of that 485 that you're looking into, you can kind of see what's available there for the menu options.
All right, next one. Can you trend the microamps? Oh, sorry, Brian, do you have more?
I did want to clarify just for if there was any confusion about V1 or V2, that it supports on both. Okay, all done.
Thank you, Brian. Next question. Can you trend the microamp reading, so that's like the leak detection current, on the Wi-Fi LD sensor?
Yes, you can. We send kind of what our standard assumption for what a leak is. We send that as the first part of the packet data, but then also we send that microamp leakage current that's published online, so you can see our documentation there. I'm not sure if it's posted yet, but I think it will be soon.
Well, and really what you're trending there is
I have heard it will be posted today, so.
So on the trending of the microamp, I mean, really you're trending at zero value until a leak is to occur, or some condensation or some conductive fluid is able to trip that alarm. So not exactly sure why you would want to trend it, but if you want to trend it, it is a reading that is generally being communicated through the wing sensor, wing LD transmitter itself.
The way I'm interpreting the question is, like, can you adjust the threshold based off the leakage current? And the answer is yes, you can.
Yeah. Okay. Yeah, you can do that as well. Absolutely. I've actually done that.
So I believe they're thinking about contamination alarms.
Yeah. Okay. So yeah, there was a museum environment that I was able to deploy about 90 of these wireless leak detection transmitters and connect them to sensing cable. And based on that environment, what we ended up doing just to eliminate and minimize any real false alarms was actually a couple of sensors in their specific placement required a slightly higher milliamp threshold because they were directly under some vents, like maybe 2 feet away from these vents that were blowing extreme temperatures on them once they turned on. So we changed the threshold slightly, and then also put an alarm delay on it so that it would have to wait, I think it was 45 seconds or 60 seconds before it was to trip the alarm. So there's certainly some fine tuning and commissioning capabilities in the wing manager with our leak detection as well. Because what do we all not want? False alarms.
All right, next question. What is the maximum cable length on the wing manager relay output for camera applications?
Yeah, I know in the past we've kind of said like 100 feet is like a good rule of thumb. It does depend on the type of wire, right? So you feel like really robust, like 18 gauge wire or something, you probably go really far. You know, if you're using 28 gauge wire, you won't be able to go as far. I can't give exact numbers, but pretty decent.
You can circle back on that one. And
all right, next question. What file types are acceptable for integrated mapping, and how do we get the map into the wing manager?
I believe it's a JPEG, right? And it's a single picture, and it's really as simple as just selecting it off your desktop and inputting it into the manager. And then from there, what you would do is basically select all the data points you want to overlay on that image. And we can certainly go through a more specific demo application of that, maybe in a future, probably be a good future little 1 or 2 minute little video, Jen.
Yeah, the manager supports image files for the map. So if you're using a different type of map, hopefully there's some way you can export that to an image and upload that. I don't have a completely exhaustive list of each image file type that's accepted.
It's for sure in the user guide for the Wing Manager V2. And it talks about which image files you can use and the specific sizes that the image file needs to be. And then you go through the manager, and the points you're mapping are kind of an overlay that sits on top of that image you upload. All right, next question, guys. For a large wing one-wire installation of, say, 4,000 plus freezers, how would we actually find the sensors if they were moved? Is there a way to determine what wing manager and antenna they are connecting through?
Yeah, freezers. Wow, that's a fun job.
Yeah, one thing I just wanted to clarify is right now the one wire is only available in Wi-Fi, not wing flavors. So we don't have like RFID trackers to track like where they're placed in your environment. And we're not sending the wireless access point information to the manager for security reasons. So we can't track in that way either. So there needs to be some control of the physical access of the sensor, and that, that'd be true for either type, wing or Wi-Fi.
Yeah, when I looked at this question, I was thinking too, like for the transmitters, you can mount them and you can screw the Wi-Fi transmitter into a location. So it would be harder to move than the one-wire sensor. And then Brian, you can, like when you configure the sensors, can you talk a little bit about how like you can associate specific sensors with specific managers and then keep them locked into that setup?
Yeah, like there's the discovery process. You can either do it automatically or manually to control kind of which sensors are being there. You can type serial numbers in manually if you want to do that. There is a channel pair difference. Like especially if you're doing like multiple setups right next to each other, you can put them on different radio channels so that you're not getting interference from the other. And then for the Wi-Fi sensors, like I don't know if I'm going off base here with this question, but you can, when you're connecting, there's an option to go through the CLI and send packets. So that way when you're setting up, it actually works the exact same way as the Wi-Fi sensors. You send some packets and then you can detect it in the Wing Manager if you are using Wing Manager for that application.
Well, and all of the
Thanks, Brian.
all of the sensors have.
Oh, go ahead, Mike. Sorry.
Oh, no problem. All the sensors do have a name and a location that's in the sensor name, right? That you're kind of configuring when you or typing in when you set it up. So, I've seen in the past where if a sensor did walk away, let's just say, it would show an alarm stating that that sensor is no longer communicating in the manager, right? So that's some of the alarming that we can create as well. So, if it's just a single sensor, you got to be mindful of where you're putting it and how you're naming everything and kind of the nomenclature that you're using. But yeah, there is no of the RFID kind of location tracking on those sensors either. So.
All right, we're getting right up to our hour mark, but we have two more quick questions. What is the character limit for the username and password on Wi-Fi sensors?
I don't think I know that.
I need to look it up. My guess off the top of my head is it's around 30 characters, but I'm not positive. Send me an email.
Ted gets the gold star for stumping our engineer today. So gold star for you, Ted.
Nice job.
I do appreciate people putting the comments in the chat. That gives me a little time to look stuff up.
All right, last question for you all. When should I use a Wi-Fi-TH versus a Wi-Fi one-wire sensor? What are the, like, why do we have two sensors that do similar things, and when is one preferable for use than the other?
In my opinion, I think it's placement of the type of temperature humidity you're trying to grab. So the Wi-Fi temp humidity is, you've seen the pictures in the presentation here. I mean, it's about the size of two decks of cards stacked onto each other, and it makes for an easy wall mount in any kind of a standard room or office space, or, we've even used actually on a large scale as well, the Wi-Fi-TH in the couple of different data centers, because obviously they had great Wi-Fi in there and that was the path they wanted to take. So, with the one wire, you got a probe on the end of it. So I don't think most people want a probe just sitting in a room. If you had it in a thermostat case, then yeah, I guess that would work just fine if it was covered up. But I think I've seen that more often actually used for data center cages, but probably more frequently used inside of any kind of refrigerator freezer application.
All right. Thank you, guys. I think that takes care of all the questions we've received so far. Just so our attendees know, Mike and Brian are more than happy to answer any additional questions you have at any time. Feel free to reach out to them directly. If you have one of those more complicated installs that you're trying to figure out how to make it work, anyone at RLE is happy to take the time to sit down with you and figure out what you need and what application and what combination of our products best suits what you're looking for. The contents of this webinar will be posted. We've recorded it. They'll be on our website. If you need to go back and reference anything, if you want to share the link with anyone else who you think would benefit from this information that wasn't here today, it'll be up within the next day or so. And we really appreciate you spending time with us this morning.